All right, in this video, we're looking at sigma notation. So it's this big, scary looking sum sign that looks like this, and we'll learn about what it means. So the best way to do this is just a couple of examples. So we could use sigma notation to write something like this really long sum here, 1 plus 2 plus 3 plus 4 plus 5 plus 6, all the way up to plus 72 at the end. So what we tend to do is have an indexing variable. So we tend to call it k. So for example, for that term, k is 1, for that term, k is 2, for that term, k is 3, and so on. So really what we want to do for this sum is write it as the sum of just k, and k is going to start at 1, and it's going to end at 72. That's how we'd write that sum there. Similarly here, k could be 5, k could be 6, k could be 7, and k could be 8 there. So this would be the sum k equals 5 to 8 of just k on its own. Now that's one way you could write the sum. Another way you can write the sum is you could use a different letter like j. So 5 to 8 of j on its own. That would also be correct for the sum. And then you could get really funky and think maybe I'm going to use a different letter. Let's use I. So this 5 could be 0 plus 5. This one here could be 1 plus 5. This one here could be 2 plus 5 and 3 plus 5. So a perfectly valid sum there would be to go the sum from 0 to 5. I'll use k again. And it's actually k plus 5. So if you read off that sum there, when k is 0, we get 5, then 6, then 7, then 8. And my apologies, that should only go from 0 to 3, not 0 to 5. Your calculator can also do sums. So if we go into math and then scroll across to this sum symbol, so if we wanted, we use x instead of k here, but x is 5 up to 8. There it is, 26 is the answer. And if we do 5 plus 6 plus 7 plus 8, we also get 26. And if I pick this other wacky one, so I do the sum there of x plus 5 from x being 0 up to 3, I get 26 as well. And if you want, you could even do x plus 4 from x is 1 up to 4. And you would also get 26. So there's many ways to write these sums. Anyway, it gets a bit messier when we're looking at like square numbers and stuff. So this number I can write as 1 squared and 2 squared and 3 squared and 4 squared and all the way up to 10 squared. So the way I'd write this sum is the sum k is 1 up to 10 of k squared. So we're not going 1, 2, 3, 4, 5. We're actually going 1 squared, 2 squared, 3 squared, etc. Similarly, this one here, this is 2 to the 1. This is 2 squared. This is 2 cubed. This is 2 to the 4. All the way up to this number here is 2 to the 8. So this would be k is 1 to 8 of 2 to the k. Very good. Another way you could write this sum would be going from 0 to 7 of 2 to the k plus 1. That would also be perfectly valid. Both these mean the same thing. Okay, 1 plus itself 43 times. Well, we know the answer is 43. But this is just the sum of 1. And k can go from 1 up to 43 if you want. So it's a bit silly because k isn't showing up in this sum. But what that means is it's 1 plus 1 plus 1 plus. And you're doing this, well, when k equals 0, this thing's still 1. When k equals 1. When k equals 2, that thing's still 1. When k equals 3, that thing's still 1. And all the way up to k equals 43, that thing is still 1. And if we want to verify that on our calculator, we can. So if we just go 1, and we're going to go from x is 1 to 43. There we go, 43. This one's a little bit nastier. So this one you can write as 2 times 1, 2 times 2, 2 times 3, 2 times 4, and 2 times n. Now the number that's sort of increasing by 1 each time is this. Your number does have to increase by 1. So for example, here it was that number 1, 2, 3, 4, all the way up to 8. And here it was the base, 1, 2, 3, 4, all the way up to 10. So in this case, the number is just the number times by 2. So this sum here will be 2k from k equals 1 to n. Sometimes people use I instead of k. I tend to avoid that just because I is already used in math elsewhere, so we try not to use that if we can avoid it. All right, Sn. So Sn, what this means is it's the sum of all the terms of this sequence. So I think that would be T1, T2, T3, etc. And if we look at S1, that would be 1. And if I look at S2, that's 1 plus 4, so it's 5. If I look at S3, that's 1 plus 4 plus 9, which is 14. Cool. So I can keep going on like that. Anyway, this is written like that. But for Sn, we can write this as 1 plus 2 squared plus 3 squared plus 4 squared plus 5 squared plus, and it would go up to n squared, just like so. And then we can write that in sum notation. So k is 1 to n of k squared. Cool. So if we want, we can evaluate this for n equals 1, 2, 3, 4, 5. And what I'm going to do is chuck that into the calculator. And we're going to go sum, and we're going to go x squared instead of k squared. But we're going to go from x is 1 up to whatever our n value is. So if I pick 1, I'll get 1. If I pick 2, I should get 5, like what we just saw up there. So that's S2. If I pick 3, I should get 14. If I pick 4, I'll get another term on the end, so I should get 30. And then if I pick 5, I get 55. I'd actually encourage you to try and look for patterns in these numbers because we're going to be seeing some of these sequences very soon. Okay, expand and evaluate this. So we'll do it by hand first. So when k is 1, I'm just going to write underneath, k plus 1 is 2. When k is 2, k plus 1 is 3. So you're essentially going to get 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8. And the 8 will be when k is 7 because 7 plus 1 is 8. If we want to work this out, you absolutely can do it without summation notation. There we go, 35. But if we want to use summation notation on the calculator, it's going to make it much quicker and easier for us to do that. So this would be x plus 1, and x can go from 1 up to 7, and you get 35 as well. Okay, let's look at the next one. So for this next one, k is 1 to 5 of 1 over 2 to the k. So what that means is that is 1 over 2 to the 1 plus 1 over 2 squared, 1 over 2 cubed, 1 over 2 to the 4, and 1 over 2 to the 5. So that's a half plus a quarter plus an eighth plus a 16th plus 1 out of 32. I reckon it's going to be 31 out of 32, but let's see if we can figure that out exactly. So I'm not going to bother typing all that out, but what I will do is just go into the sum. 1 over, and then we're going to go 2 to the power of x. Just going to use x instead of k. X is 1 up to 5. There we go. 0.96875, but more importantly, 31 out of 32. There's actually something really fun you can do with this sum as well. If you think about what's happening with this, well, it's just getting closer and closer to 1. So if I pick a bigger value like 20, I'm going to get 0.999999. And if I pick an even bigger value like 50, well, that's not exactly 1 because you're still a little bit short, but your calculator eventually just gives up and rounds it off to 1 because it's so close. A good analogy for this is you're trying to color in a square. It wasn't a very good square. And you start by coloring in half of it. And then you color in half of what's left, and then you color in half of what's left, and then you color in half of what's left, and 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 half of what's left. And you're always slightly short of the full thing being colored in, but you're going to get really, really close. And if you let this sum go up to infinity, so k is 1 to infinity of 1 over 2 to the k, you have to be a little bit careful how you define this formally, but it seems like it should equal 1, which is really cool.